In item number 2 on the first test for fall 2015, we're given a truss-like structure with a weight that's being hung at the end, but it's not just being hung as a rope or a cable that passes over a pulley and then attached to the wall. We are asked to find the horizontal reaction component at point G. And is common in these kinds of problems. The first thing we're going to do is draw a free body diagram of our situation. And so you get out your trusty straight edge, and you're going to then get everything that's of significance. We're going to cut the cable here, pull the pin and the roller at the support. We do not need to represent all the internal workings of our system. It's good enough just to have that kind of object sitting there. We've got the weight being pulled down here, that cable force, and it's a single cable, so it's going to be the same tension all the way through. And then we've got at the pin 2 independent reaction components, and we have down here AX at the bottom. I don't really know which way GX is going to go, but if I were to pin this at G, I would think that I probably have some sort of net swinging action in a clockwise fashion, meaning that this boom wants to push into the wall at the bottom, so the wall will want to push back. And that's why I'm setting up and guessing that maybe GX goes to the left. But of course, I don't really know if that's the case or not until I do the work. Okay. So, we've got as our second step then to write equilibrium equations. And since all we want is GX, I'm going to look for if there's a way to write a single equation that will give me GX. Now, if I write sum of forces in the Y, I get AX, GX, and T into it, but I don't know AX, so I'll have too many unknowns in that equation. But if I sum moments about A, I will knock out GY and AX. I do know T in terms of W, and so I'll be able to get GX in terms of W, and I really like that. So that's what we'll do. We'll sum moments about point A. I'm going to take counterclockwise as positive because the way I've got it set up, that's the direction that GX would be positive in. It's got a moment arm of 2 meters. So 2 times GX minus then a moment arm of 5 for T plus then 6 W. Oops, I got those backwards, didn't I? That's going to be a plus 5T and a minus 6W. And that then gets set equal to 0. So that GX then is equal to 6W minus 5T all over 2, since T is equal to W, as it's a single rope over a single pulley, then that means that GX is over 2. So to solve then finally truly for GX, then we're going to want to substitute in, or not substitute, we want to calculate W as equal to mass times acceleration of gravity. We got 60 kilograms, that means for SI systems, so 9.81 meters per second squared. Divided by 2, kilogram meter per second squared is going to give us a Newton, and so that's going to tell us that numerically our reaction is 294.3 newtons, and for then a final answer, we will have that GX is equal to 294 newtons, and it's acting to the left. There's your answer.